Okay, this vector v can be specified by simply how far do we have to go in the x direction and how far do we have to go in the y direction to get from the initial to the terminal point. Now what I said isn't quite exactly right. It's not only how far we've got to go in the x direction, but how far and in what direction we got to go. And how far and in what direction do we have to go in the y direction. Which means that I could draw another vector purely in the y direction and call this v sub y, and another vector purely in the x direction and call this v sub x. Okay, to get from the initial point to the terminal point, I can go along the vector v sub y, and then from the terminal point of that vector, I can go over to the terminal point of the vector v when it's drawn from this initial point. And if I do that, well, the very same vx and vy not very well written. I wrote a y when I meant to write a v. But anyhow, the same vx and vy will get us from the initial point to the terminal point of the vector if the initial point is here. Okay, so now we can say that the vector v is equal to vx, vy. Now vx and vy are in fact vectors, but I don't put arrows over these. I'm just going to use numbers because vx is either to the right or left and vy is either up or down. So if I put if vx is a positive number, that means that our vx vector is to the right. If it's a negative number, it's to the left. If vy is positive, well, it's up. If it's negative, it's down. So in this case, both the vy and the vx that I put into this form would be positive. But for another vector that goes in this direction, well, one of them could be negative. Okay, well, this is the notation. Now let's go ahead and put a scale on this, okay? Now if this is a class and interactive, I'd say, okay, go ahead and stop me someplace, and that's going to be the unit. Well, let's say you tell me to stop right here. Okay, so if this is a unit, then I'm fudging a little here just to keep the numbers reasonable. And really I should have the same scale on the y as on the x if I want these vectors to look right, and I kind of didn't do that, but you could redraw this with a good scale, okay? Well, the initial point looks like it's 3, 2. And the terminal point looks like it's what? 1, 2, 3, 4, 5, that's around 6. And this is, well, 1, 2, 3, 8. So the terminal point appears to be 6, 8. Now, if the initial point is 3, 2 and the terminal point is 6, 8, then what's vx and what's vy? You should be able to answer that. You should really probably pause and answer it. Pause the video and come up with your answer. Well, whether you do or not, we could even count on the scale here. Vx starts here and ends here. That's 1, 2, 3 units. And of course, 6 minus 3 is 3 units. So I'm going to say that v equals 6 minus 3. And we're going from 2 to 8. That's from here, 1, 2, 3, 4, 5, 6. I can count 6. Of course, I can subtract 8 minus 2. So that vector is the vector with components 3, 6. Okay, so now we see a vector can have components. We call this the x component, this the y component. The x component is 3, the y component is 6. Now there's more we can do with this vector.